In this exercise we're going to get you to measure the coefficient of friction between a simple wooden block and a piece of timber. Now we'll also discuss the theory of this in lectures, but there are two different methods we're going to use to measure the coefficient of friction. This first one simply involves placing the block on the piece of timber, and we raise the end of the piece of timber up until we find the angle at which the block just slips. Now, as we go through the theory of this in lectures as well, gravity at that point was pulling vertically straight downwards, force mg. The two components of gravity acting on the block were the force parallel to the slope, mg sine theta, where theta is this angle with the horizontal, and the component of gravity acting perpendicular to the slope was mg cos theta. Slipping happens when the coefficient of friction is such that the horizontal force, or the force parallel to the slope over the normal force, is equal to the coefficient of friction. In other words, when mg sine theta over mg cos theta, sine theta over cos theta is tan theta. The coefficient of friction, the point of slipping, is just the tan of the slipping angle there. Let's just refer to the diagram in your lab manual relating to this situation. And as we've discussed, the coefficient of friction, μs, is just the ratio of the horizontal force down the slope, mg sine theta, over the normal force, mg cos theta, or sine theta over cos theta, which is just tan theta. So all we need to do is determine the tangent of this angle here, tan of theta, at the angle at which the block just slips. Now you might think, why not use a protractor? Well, it's rather difficult to measure small angles down here with a small protractor. We get a little bit more precision actually if we use a metre rule and measure the length of that piece of timber to the nearest millimetre, of course, and so that'll be a measurement to within 1 part in 1,000 or better, because that block of timber, that plank, is a bit over a metre long. And then just you raise the block until you get the angle that it just slips, and then have someone very quickly measure the distance from that bottom edge there to the table. Not the top edge, from the bottom edge to the table, because there's our triangle there, from the bottom edge there, down to the table, across to the apex there, and there's the hypotenuse. So, you write down the value of y. At the beginning, just once, we measure L. Each measurement you then measure y. So you have a table of data, write down your y value. What do you want to calculate? The tan of the angle. We don't actually need to know the angle itself, we need to know the tan of that angle, opposite over adjacent. But we've measured the opposite and the hypotenuse. So instead of y over x, we have to calculate the x. Pythagoras' theorem, y squared plus x squared is L squared. So x is the square root of L squared minus y squared. So instead of the x there, x is the square root of L squared minus y squared. So you've written down a value of y for this one measurement. You already know the length of the plank. Next to the y in the next column, you calculate that value, write it down. There's the coefficient of friction. You do this measurement 10 times, very quickly, get 10 measurements of the coefficient of friction, and then we can do our statistics on those measurements, work out the average value and the standard deviation of those values.